So after using the ratio test, you're gonna have this.
Oh, that one.
Correct?
Yeah.
Ratio test. Remember, ratio test is an plus 1 divided by an. Because you divide an, that's when you need to flip this guy. Okay, because you flip the guy, that means you divide it. So what can we do? This guy and this guy, they can cancel out to have left only x minus 3, right? Because this means you multiply by another x minus 3. That's why they get 1. So you cancel this guy, you have this. And you have n over n plus 1. Is this only less than 1? Right? This is only less than 1, right? N over n plus 1. For example, 5 over 6. Less than 1? The bottom already at the top. Okay, so this is less than 1 already. Now, the two things happen. If you have only this, less than 1, then this will be your radius of conversion. Right? You need this one to less than 1 to be convergent. If you have some number inside here, this is still the radius conversion. This is going to be just a center at 3. Sometimes they ask, what is the center of conversion? Center at 3. But the radius is still 1. Okay, so the answer is still 1. Now, when this number is going to be changed? When you have something like this, for example. Right? Then you need to take care of the bottom. You need to take care of the bottom. So you will multiply both sides by 2, right? Then your radius, what is your radius of conversion? 2. What is your center of the conversion? 3. Make sense? Usually this question always on the MCQ most of the time. So I hope you're gonna get the point for this. Series sum infinity. Okay. Sum from 1 over n squared. I'm gonna go fast, but record it. So if you you can ask me a question when you review it. Divergent or convergent? What kind of series is this? What kind of series is this? P series. So convergent or divergent? Convergent. So convergent or divergent? Convergent. How do you know when it's convergent? Between greater than 1, right? So easy. Convergent by this. Got it. You got it. Hi, Jay.
Mr.
Okay.
I checked. I think we only need 48 out of 108 to get a 3. So I was like,
Think about this. Easy to pass. Actually, easy to pass. Think about this.
Yeah.
Okay. So, but don't let that pressure you. Actually, it's easy to pass. I can say the amount.
and then when
The amount of knowledge that you learn already, I think is already enough for you to pass. But always aim for a higher score.
Yes.
Okay. All right. What about this? I think this is going to be tricky for you. Anybody? 15. Make a start. 15. Some question is tricky. Make a start so you can come back. Make sure you do it right. What is this? Huh? What series pop up in your mind? First, you see this. It's going to be alternating series. Do you remember how the alternating series is going to be conversed? Oh, good answer. 2 days before the test. Alternating series only convergent for 2 things happen. First, they need to be decreasing second. For example, 1/2, 1/4, 1/6, 1/8. They're decreasing, right? And then they need to go to the approach is to 0. Review the paper of series. Okay. Now look at this guy. 1 over n. If you don't then you don't need to consider this guy anymore. Just consider what we have left. Is it decreasing function? When n increasing, is it decreasing? You have n from 1 to infinity, right? So you're gonna have n over 1, 1 over 2, 1 over 3, 1 over 4. Is it decreasing? Yes, so decreasing. Check mark, done. Is it going to 0? Yes, it approaches 0, right? Because 1 over infinity is 0. So this is convergent. Now you have 2 things. You have 2 options.
conditional.
Convergent absolutely or convergent conditionally. So how do we know?
Conditional.
You need to take the absolute value,
Oh.
right?
Yeah.
But oh yeah, how do you check this? You need to take the absolute value. So I know this is convergent. Now if I take the absolute value, what do I have? The absolute value take care of the negative, right? No more negative. So what do I have is this guy only become 1 over n. Now, is this convergent or divergent?
Divergent.
1 over n?
No.
Yes.
I thought we just did harmonic.
Convergent or divergent? Convergent? Divergent. Divergent.
So it's
What is the name?
harmonic? No?
Harmonic series.
Yeah.
Harmonic series is always divergent. Okay? Harmonic series always divergent. Review all the sheet series, the sheet paper. Review all that shit. Mister, you are recording. So, because when you take the absolute value, it's actually divergent. So, what is the name? Conditionally. Okay, conditionally. Speed, easy. Yeah. Question, yes.
Somebody's calling you.
Cindy.
So, is it stop now? Still?
Should I answer?
No? It's stop now to record it?
It's recording.
It's still recording.
It's still recording? Okay, good then. Thank you. Is how do you find the speed? How do you find the speed? Square root of?
dx over dt squared.
Are they going to the store to buy a calculator?
Wait for speed.
Mister, I think I need to go help soon. I'll be back.
Square root of dx over dt.
dy over dt square plus dx over dt square. Right? So it's going to be what? 2 negative sine t square plus 2 cosine t square. So you have 4 sine square plus 4 cosine square. What is that then? Can we factor out the 4? Then sine square plus cosine square, which is?
Wait, I actually gotta get one.
Sine square plus cosine square is? 1. Okay? So you have square root of 4, which is? Yeah? Good job.
Everything's simple.
Now
We are actually cooking.
Yeah? Good job, good job.
Cooking was
I'm gonna go fast, we'll have 1 hour. This is the last time I'm gonna meet you. So I still need to show you how to do a slope field. You remember how to do a slope field? If not, we can talk about this on Sunday. Okay? You guys using the calculator. Do you need a calculator take home to practice?
Yes.
I can give you calculator take home too.
Wait, but
Make
I thought
sure-
we erased it.
Make sure. Oh yeah.
Wait, mister, we could just do it online.
Yeah, online.
Okay. Then Monday, make sure you come here, take a picture, get a calculator, and go. Okay. Right. Yeah, take a picture too. Take all the t-shirt. Wear a t-shirt. You come here
Mister, can you send a
early.
message on Sunday?
I'm gonna be here early. I'm gonna wait for you to come here
Mister, they don't open the gates till like 7.
until 7:38. Yeah.
With the other one.
Two of them don't have stickers, and I think the ones with stickers are two of them have no stickers, so.
You can just say same as above. Do you see my guy? These 2 students? Do you see 2 students also looking for this? Are they there? No?
Joshua.
Joshua and David? No, okay.
Yeah, they can. Yeah.
Okay, yeah, call them. Yeah, call them to come back.
Should I lie?
Oh, really?
They saved them when they do it.
Alright, there, okay. 17? Alright, dy over dx is dy. Oh, easy, right? I think we can do it by ourselves.
I
Yeah?
can't read it. I can't.
Yeah, can you rewrite it for us?
Yeah.
X equal to t squared plus 1, y equal to t cubed minus 1, minus t. And you're gonna find dy over dx when t equals to 1. Find the derivative of this, divided by the derivative of this, plug it in 1, that's it.
Is that T?
When you flip to the last page, there are solution for you, okay? So you can check your solution.
Call me out.
I make a copy for you.
Oh, you texted me during the tree shooting.
Yeah. You didn't come.
My bad. I forgot.
But where is it?
Actually, yesterday went by pretty fast. I was because I saw it at the end of the trip.
Okay.
Okay. Check my phone.
I'm running with the time. So let's do polar.
What?
Area enclosed. You remember the area? Oh, we need to talk about the area. What is the area of the polar? Formula. I recommend write all the formula the night before, so memorize it. Okay. What is area of polar? What number 2? No square root. Alpha, beta, yes. Sigma. 1/2 of what? R square. D theta. Okay. Very good. Have you ever confused about area between the curve and area using this? Area between the curve, because you have two curves. You're gonna do top minus bottom or right minus left, right? But this guy is special. Why? Because this guy they have a loop. This guy is something like this. The polar is something like this.
pedals.
They only have one function. That's why they're different from top minus bottom or right minus left. Okay? Don't be confused. And the Sharon dishwasher is about volume, not area. That's different thing. That's why they have different formula. Okay? Yeah, Isabel, do you say something?
Cleaner your tables.
Don't worry about it. Yeah. Just so I'm gonna clean it. Just so I'm gonna clean it.
You suck.
Alright. Oh, you're gonna use sub. Use sub for me. R equal to cosine theta. Like washer yesterday, someone say washer method?
Oh, I remember.
Who said that? Oh, yeah, right? Okay. Yeah. R, plug it in here, straightforward. The tricky part is to find alpha and beta. Okay? Write out a note. I'm gonna tell you this. This guy is the tricky part. How do you find this? Usually 80% or 90% of problems, you're gonna find this boundary by letting R equal to 0. Because you're literally finding the intersection, do you agree? Right? Or like this. Something like this. You're gonna find where to stop. And usually they stop at when they cut the x-axis, so when it's R equal to 0. When the radius is 0. So let's 2 cosine theta equal to 0 and you solve for it. That means cosine theta equal to 0. Yeah, and then, do you know how to solve this? Cosine function look like this, right? Cosine function look like this. And then they start 0 from negative pi by 2 to pi by 2. That's your alpha and beta. See, this one is easy to plug it in, but the alpha and beta is usually the tricky one. Okay? So 1/2 negative pi by 2 to pi by 2. Cosine theta, so 4 cosine square theta, d theta. Now, how do you take care of the cosine square? That's another thing. How do you take, okay, 4 divided by 2 is 2, so we have 2 here. How do you find the integral of cosine square d theta? How do you take care of this?
That's 1 over. No.
Something like fraction, yes.
1 over sine squared.
No, then you're gonna have integral of sine square. Then how do you do integral of sine square? You just go back and forth. Jigsaw is long.
Oh. So get to go.
So it's good to review this, okay? Cosine square, you're gonna using half angle identities. Remember half angle identities?
Oh,
1 plus cosine 2 theta over 2. You remember this?
Yeah.
Because now they don't have any power, and then you can just do the chain rule, and that's it, right? So this is going to become 1/2 plus cosine here over 2. You have 2 outside. So 1/2 theta plus 2 gone. Oh, yeah, actually they're all gone. 42 all gone. So you have 1 just theta plus, what is the integral of cosine 2 theta? What is integral of cosine 2 theta? Sine 2 theta and over 2. Chain rule, right? Chain rule this and you divide it, and everything go from negative pi by 2 to pi by 2. Okay? Do it by yourself. I'm gonna let you again answer on the back. So try by yourself. Okay, we need to go fast. Polar area formula. Oh, we just talked about this. Easy, right? 1/2 integral r squared d theta. That's just formula.
Oh, just ask you for the formula.
Now, if the polar is something like this, like intersection, you have something polar here and some polar here, then what you gonna do? You find the alpha and beta by intersection.
Yes.
Yeah. Here, there's no intersection. That's why you're gonna using this. You're gonna using this guy. But if they have intersection, you're gonna let two functions equal to each other to find this is the alpha, this is the beta. Yeah. Yes.
Mister, if we have the calculators, would we be able to use like the intersection thing on there too to find it?
They do, yeah. Did I show you? We did try to do intersection, right? You're gonna put two function, and then find the intersection. Remember, press enter 3 times. The last one.
Mhm.
Huh?
Are the calculators charged?
Yeah.
They're all right.
Yeah. Yeah, for sure on Monday it's charged. By Monday.
Are you gonna check this like they still have the program?
I'm gonna do it right now. I'll bring my laptop to do it right now after school maybe.
Are you gonna have download?
After school, yes. Yeah.
You should get Desmos on
I don't think they can.
there.
Bro.
Who's getting?
You can use that more on the test, right?
Yeah, we have
Yeah.
this.
Yeah.
No, what I did
Euler method. It just seems similar to the linear approximation. Okay. Y. Do you remember point slope?
Yeah.
Point slope is y equal to mx minus x0 plus y0. Point slope, right?
Yes.
Y minus y0. I remove y0 here. So linear approximation and Euler method are the same. But Euler method is more accurate because they take in the step. Do you remember the step?
Oh yeah.
So for the Euler method, they're gonna give you 3 information. The step size, x equal to something like 0.5 or 0.25. You remember that lesson? Every step. And then they're gonna give you the initial value. And they also give you dy over dx, the slope. Okay, these 3 information that you need to do for the Euler. Now, what is the formula for the Euler method? Just review your note. But based on this way that they're saying is y new, the new one. The next step equal to y0, which is the O1.
Initial, yeah, like
The O1
the
plus
one before.
plus slope, right? Just based on the point slope. That's how I remember this. Linear approximation, Euler method, the same thing as linear point slope. Y0 is a YO. M is the slope. What is the slope? Do we know the slope?
Like,
Yeah? They will give you. Okay? So plus dy over dx. And then x minus x0 is just the h. That's the Euler. That's it. So I think one more question they will talk about specific Euler method. But what the answer then? YO plus, okay, this guy, right? YO plus h times f. Yeah? Let's see what question they have Euler. So maybe. Is there any Euler method? Oh, right here. Euler. Go to the question 33. We can do this one together. To practice the Euler. Mario, you have my paper? Inside your paper? Don't give up. We have 2 days. Only 2 more days.
Do you still have it, mister? The one that you
I'm gonna copy it now. I can apply. Can I leave it somewhere?
No.
It's the Hamza and Martin. He's like,
Even you have a feeling you want to give up, but remember, you have been trying for the whole school year. Okay? This is the last 2 days. You should try whatever you can, so that you don't feel guilty later. Hey, I tried for the whole year. Now just 2 days, I'm gonna give up? No. Never give up. Okay? Don't. I know. It's very easy. It's very easy to check out when you don't understand stuff. When it's so hard, and you're like, I'm gonna check out. Everything gonna pay off. Okay, so try it. Just 2 more days. So after that, you're gonna feel satisfied and the UT. All right.
Guilty?
Not guilty. Be satisfied.
You feel UT like, for example, oh, all my friends passed, but just 2 more days I didn't do it, and then I failed. That's UT. Okay, you also give you initial value. See it? This is the asking you. Okay. Did you know the step? The step size 0.5. Now, which one they give you? They give you y0. That's initial value. From zero to 1. They ask you to 1. How many steps do you need? If the step is 0.5, 2 steps, right? From 0, they know you start from 0. You need 2 steps to get to 1 because each step is 0.5, right? So now let's do n, x n, y n. This is exactly on the note we learned about order. Y0. So when n equal to 0, y equal to 8. So now, can you plug it in 8 here to find dy over dt?
Yes.
So 8 over 8, 6 minus 8, so you have -2, right? So this is y1. Let's write y1 is the new, equal to y0 plus h times the derivative dy over dt. I'm gonna find a new one, okay? Yeah, so we got this. Okay, we want to find y1, but this is gonna be two step. Okay. 0. So y0 is 8. Yeah, y0 is 8. Plus h is 0.5 times -2. So 8 times this is 1/2, -2 is 1. So 7. So they're gonna be 7 here. Right? Next step, you should do every step. Every step.
Wait, so they have value left to do?
Mister,
Yeah.
I just realized that today I'm gonna eat unspeakable. Wait, they're having this and
So next step is 1. Right?
like you can go down it. Wait, I don't know if you can get some, but like it's like 3 downstairs.
Okay. Yeah, I like that. I like that idea. Let's get to continue. Y2. We can talk. Okay, we can talk. Y2 go to y1 plus h dy over dt. But now dy over dt is a new one. You're gonna using this 7, plug it in here. You're gonna calculate the new slope every time. Okay. So dy over dt equal to 7 over 8. 6 minus 7. Oh, where are we gonna go? T. I knew it. Negative 7 over 8. So that's going to be, plug in here. Y1, what is the Y1? 7. Plus h, what is h? It's fixed, right? Fixed, the 8 is fixed. This one fixed. So 0.5 dy over dt, negative 8. So they're going to be 7 minus, this is 1/2, so 7 over 16. So 7 times 16.
I don't know what 7
Yeah?
Okay.
112 minus 7 is 105. 105 is 16. Oh, where do we go? Are we good with Euler now? Review the Euler method. So basically, write out everything you need to know. We need to know the h, because the formula they always have h. You need to know this. Usually dy over dt they're giving, okay? Using the step. This is the number of the steps. Step 1, step 0, step 1, step 2. But then up each step, the x will increase. Increase from whatever they give you. Initial is 0. After one step, increase to 0.5. After second step, they increase to 1. They keep going. The one keep changing is the y. How is y gonna changing? They're changing based on whatever you use for formula. Review the Euler method. Okay?
Yes.
Alright. So let's go back. 17. Where are we?
So we're like 20.
22. McLaurin. What does McLaurin look like? What does the Taylor series look like? Taylor series look like?
Sigma.
3 part, remember? 3 part?
Yeah.
First part is the derivative, is for accuracy, remember?
Yes.
So f of a, right?
X.
Second part is what?
X minus A.
X minus a to the power n. And the last part,
And factorial.
why we need the
Cancel
factorial,
out.
remember?
That's for.
To cancel the when you take the derivative, they have the factorial to cancel out. This is the Taylor. Yeah?
There's like, depending on the series, some people zero or one.
Oh yeah,
Oh, that's the other
McLaurin. And if you put a zero,
McLaurin is just that, but it's 0.
Maclaurin and Taylor, very good question. Maclaurin and Taylor, they always start from 0. But for the geometry series, they start from 1. Yeah?
Yeah.
You can also change to 0, but you need to change the index. It's just about index thing. It's not different. They're all the same. They're all the same. Okay, but what's special of Maclaurin?
One of them, the A is
Maclaurin is when a equals to 0.
It's either
So Maclaurin, I'm gonna replace everything here by 0.
Is that for me?
Surely.
Aw.
Okay, now the Maclaurin series for e to the power x, we did it in class. Let's do it again so you remember what to do it. So first, what do I recommend you? What did I recommend you to do when you do the Taylor and Maclaurin?
Do all the derivatives.
That's right. Write the function first. What is the function? E to the x. What is the first
E to
derivative?
X.
Oh, actually, this is all going to be the same, right? They're all going to be the same. That's e to the x. Now, the good thing about Maclaurin is that a equals to 0. When you plug in 0 in here, what do you get? 1. That's the good thing about this, okay? No matter what the power, the 0 is always 1. Alright, let's plug in. First, they're always 1. If you realize the first one, they're always 1. Because x to the power 0 is 1, 0 factorial is also 1. This is the original function, which you plug in 0, it's going to be 1. 1, what else? When n equals to 1, what do you have? Plus f prime of 0, x to the power 1 over 1 factorial. Okay, let's just write down. 0, x to the power 2 over 2 factorial, plus x triple prime, the triple prime x3 over 3 factorial. Now what is f prime of 0?
Oh, one.
E to the 0, which is 1. So this is the 1, x to the power 1. So you have 1 plus 1, x to the power 1 over 1 factorial is 1. Now, second here is also 1. Because when you plug in 0, when you look in the 0 to the ex, it's always 1. So x squared over 2, and then x cubed over 3, and so on. Yeah? So which one is that? B. Alright, Maclaurin is for sine x. I'll let you do it by yourself, okay? We don't have time. So I'll let you try the sine x by yourself. Same thing with the Maclaurin. For sure, I guarantee you, for sure, Maclaurin and Taylor will be on the test every year. Because that's the BC topic. Okay? If they don't have that, they don't have any BC topic. So they need to have polar and series. Yeah. How you raise your hand? Alright, n-term test is another name of derivative divergent test. Did I tell you this? No?
No.
We talked about divergent test, right?
Yeah.
Who remember the divergent test? Yes, Emily.
What happened? Wait, what is the divergent test?
Yeah.
Oh, I don't know. No, but I remember. Oh, wait, no, that's
It's a test. Yeah.
Limit of the function, limit of the sequence,
Oh, if it's
and
zero.
series.
If it's
When the limits go to 0, can we say series go to 0?
Yeah.
Convergent? No. Remember the quiz we did?
Wait, say that again.
When the limit of the secant go to 0, can we say the series convergent?
No.
No. But the other way around is correct.
Yeah.
Please try again.
Oh.
When series convergent, can we say limits go to 0?
Yeah.
The quiz.
Yes.
Yes.
Yeah.
Okay.
What?
When the series convergent, the limit must go to 0. Yeah. But when the limit goes to 0, it doesn't mean the series conversion. But here is n-term test and divergent test. When the limit does not go to 0, for sure the series is divergent. That's the divergent test, or aka n-turn test. Okay? So divergent test only to test what?
Divergent.
Divergent. That's it. That's all they can do. If you know limit of some secant doesn't go to 0, by divergent test, the series must be divergent. That's it. They cannot test convergent. Make sense? That's why the name is divergent test. Yeah? Yeah? The beautiful people, you got this. Okay? You got this. All right? Remember, you are the top rank in this school because this is the highest class. All right? Keep that in mind. No matter if you fail or pass, keep this in mind. This is the real. I'm not just saying to make you feel good. This is the real thing. You are here proving that your ability is you are the top of the school already. Okay? No matter you fail or pass, no matter this, it's still the truth is you still is the top one on the map. So keep that in mind. Be confident. Okay? Yeah?
Can you say that quote?
Which one? Don't be afraid. Yeah, don't be afraid to fail. Be afraid not to try. I'm gonna put my name there too. Mr. Bumper, I stole them. I'm gonna stole it.
25.
Alright, I'm gonna let you do McLaurin by yourself as well, okay? We're gonna move on.
What?
Total distance.
Oh, absolute value.
Absolute value. Remember, with the absolute value, what does that mean?
How it's negative and
No, that's
Yeah, no. I mean, what without the absolute value? What is that formula for?
Because then she said,
What is it called?
velocity.
With the absolute value, it's the total distance. Without the absolute value, what's it called? Displacement. Yeah. When they ask you explain what does it mean, it's the total displacement. Yeah. Removable discontinuity. What does it mean?
when there's like,
Okay. Here is the jump. The jump. Here is the removable. Because you just have a hole. A hole discontinuity, the same thing. So two silent acid, but yeah, this one. Right? Two silent acids, but they're not equal to the one at that point. So that's removable continuity. Mean value theorem. Do they warranty the value in the between, or do they warranty the slope? It's the same.
the slope.
The slope. Okay? Mean value theorem is they guarantee that the slope at any point will be there will be a point that the slope is the same thing as the whole thing. Okay? That's mean value theorem. So what answer here? B. Integral sine 3 and cosine. What method you gonna use? User. Why user? Because derivative of sine is cosine. User. Okay? Alright. Sum of. Okay. Let me tell you the way math language so when you read it you understand. You see the underscore? Underscore means the bottom. Do you see the power? The power means the top. Okay? But look at this one. Sum of Cn. So the bottom here as well. Cn times x minus 2 to the power n. Oh, radius 3. So that means the x less than 3. It's converging absolutely. That means you're gonna take a look at the power. Absolute value. X minus 2 less than 3. That's it. That's what they want you to write. So what the answer? B. Yeah. You just need whatever the x less than the radius. What is the radius? 3. Then this is going to be like this. Yeah. We just talked about this, right? What is the center? 2. Center at 2, but the radius is 3.
Oh, yeah.
Okay, calculator section. Trapezoid. You remember trapezoid formula?
Yes, base 1 plus base
Right.
2 over 2
So
times.
one, right, 1, 0, 1, 2, 3. So we have 4, 6, 5, 9. Trapezoid, F4 plus 6 over 2. Right, trapezoid, right? Base 2 plus base 1 plus base 2 divided by 2. Time. Oh, all the subinterval here is 1. But what if they give you like 3, 5, 8? What you gonna do? You need to subtract them, right? You need to subtract them. So 3 minus 0 is 3. And then 5 minus 3 is 2. And then this one, so on. Okay? Good, good,
Yeah, we
good.
got that.
All right. Hopefully you're gonna get that point. Okay. Oh, speed again. Speed. Speed. Formula of speed.
That's without the square root?
Oh, with the
Integral.
Without integral. Because the speed, if you take the integral, if you take the entire derivative of the speed, you're gonna get arc length. Arc length, right? Arc length is the integral. So take the derivative of this and plug it in. So I'm gonna skip that. All the method we already did that. Almost. Good job. Good job. dy. They asking about dy over dx when theta equal to pi over 2. Or equal to 1 plus sine theta. Okay, what you gonna do? Do you remember the formula? The formula tell you to memorize it at night before the test. Who remember? Who wants to remember or who wants to write down? dy. What is the dy over dx? For the polar. Or prime. Or prime sine theta plus the top one is plus or cosine theta over or prime of cosine theta nothing different minus or sine theta. Find a way to memorize it. Write it somewhere to memorize it. I don't know. Okay.
On the shirt. On the shirt.
On the calculator, on the calculator.
I just pretend I didn't hear anything. Okay.
We're gonna make like the AP.
This is the slope of the polar. dy over dy dx.
Guys, for if it's C.
Yeah. Huh? What? What did you say?
Confidence.
Verb if it's B.
It's on the recording. I'm gonna listen to you anyway. What do you say?
I said fart if it's C. Like, do you know like people who cough? Like to
Ah.
Oh,
So A is 1 cup and then B is 2 cup. B.
I think we have the hantavirus.
C.
Yeah. You're gonna kick you all out. Call the nurse. Call the nurse. Oh, Miss, I swear I'm fine. I'm fine.
Wait, it was like a TikTok.
Oh, so easy. So easy. When the slope changing from positive to negative, what does it mean?
How much is
Wait, what about?
Max or mean? Right? The slope changing from positive to negative. So that's the max.
So positive to negative, and F has a maximum.
Yeah, relative maximum solution to. Oh, this is easy. Oh, do you remember this technique? This technique? Yeah. What we're gonna do? What? How do you solve? How do you solve this one? How do you solve the solution? Differential equation. Remember? Right. You're gonna put all the x together with the x and all the y together with the y.
So you multiply the X?
Can I put the x on the bottom here?
No.
No, they need to be on the top. So we're gonna move this guy over here. Okay? dy equal to 2xy dx. I want all the x to be the same side and all the y to be the same side. I'm gonna move y over
Divided
here.
by Y?
dy over y.
So I know
And
where-
then 2x dx. And then I'm gonna take the integral. What is the integral of dy over y? And y. What is the integral of 2x?
2.
Right?
Oh.
And plus c. Okay, this here, so ln equal to x squared plus c. What else? How do you get y? E, because you see in ln, you're gonna do e. This is gone. So y equal to e x squared plus c. What else? When you stop here, you look at this here. Oh, not yet. Not done yet. Okay, keep going. Is it the same thing? Is it the same thing as c e to the x squared?
Yes.
Right? Same thing?
Yeah.
Because c is just some constant. I'm gonna like write like this, e to the c, right? The same, right? With add power. So I break them like this. But this one it just means another constant. Do you agree? Just another constant. I can also write c. Now, how do we figure out the c? Initial value. Y of 0 is 3. That means x equal to 0. So y equal to c, but this one is going to be 1. Right? E to the power 0 is 1.
Oh, so.
This in Vietnamese they call se, that's right. Equal to equal to 3. Yeah, sometimes they call, what is it called? Dialect? No, no. Anyway, just go back.
Yeah, I'm really sorry.
I know what you mean when they sound the same and like.
No, I mean, do you switching code switching?
Sharing.
I don't know. There's a term. There's a term.
Idioma?
Code switching or something. That's a term.
Oh my god, Mr.
Sometimes I talk to my mom and also using English. Sometimes you cannot forget. You just forget. Alright, C equal to 3. So my answer is y equal to 3 EX squared. There we go. Yeah.
Oh no, like I had a different question about
Yeah.
math. But like, so like you know how like identities,
Right.
like some of them like there's 2 tans for the identities. Like, what do you know? How do you know what identity to use? Like for a question.
It's literally by the what question they're asking. It depends on the question, and also mostly by the experience you do when you know which one you're gonna use based on the question.
Oh, like which one suits the situation best?
Yeah.
How did we get C? I mean 3.
3 because they give you y0 is 3 here.
Oh.
So you plug in 0 here, e to the power 0 is 1. And then, so that means c times 1 equal to 3. That means c equal to 3. Yeah? Oh, logistic. We didn't go over logistic.
Oh, I know. Yeah, we did, mister.
Did we do the
We
logistic?
did.
Did we?
Yeah, the population stuff.
Yeah, the population stuff. Did we?
For like a day. I know the answer. 6.
I thought she was real. Okay. We didn't talk about this guy, right?
Yeah, we did.
It's okay, Mr. We can skip that one.
Yeah.
So I know you're gonna be on there for
That's the whole point.
clear the board.
Okay. Let's go over everything. Let's see which one we can talk about. Okay, again, this is mean, not level, this is level, right? This mean integral underscore mean the bottom one, right? The power mean the top one, okay? And then RT.
Yeah.
What it means, okay? F to the tank and RT is here, interval. How many minutes we have? 6 minutes?
6.
Yeah, I knew it.
Okay, what do you think is answer for this? That's it. Good job, good job. Yeah, good job.
Is there an answer key online?
No, it on the paper, on the back. They give you the answer key too. Work on this. We can continue this. No. Let's see what I can tell you. Have you tried all the international tests? 2019? All of them. Whatever I give you, do all of them. Do all of them. Did you do it?
Only some of them.
I didn't finish them.
Let me try something.
I don't remember, but I really had time for myself. It's
I know. This 2 weeks is very busy. But try it. Put all the effort, whatever you can. Push you to your limit. Okay. Just these 3 weeks, 3 days. But after that, you can relax and you can feel, oh, yeah, at least you won't be regret whatever you do.
Mister, we done?
Alright, so last time in class we done the 38, right? The unit is gallon, and then now 39. So the sum of n factorial xn over 5 to power n. Radius of conversion. What tool? What tool we're gonna use to find the radius of conversion? The ratio test we talked in class today, right? We're using this to find the radius of conversion.
Wait, there's the
The
ratio
power
test
series.
and then what was the other test? The root test.
Ratio test, root test,
And then there's
integral test,
integral test.
divergent test, comparison test.
And then ratio test is when like
The ratio test is the one that you increase everything by 1.
one that's like factorial.
Yeah. You see factorial here?
Yeah.
But whenever you see the radius of conversion or power series, that's you're gonna using ratio test. Okay, so ratio test, what you gonna do? Absolute value n plus 1.
No, no.
You increase everything by 1.
I
And then you divide everything, you divide by the original one.
during this one, I went to the restroom, so
Oh,
I
okay.
was,
Alright.
Okay, alright, alright.
I wasn't present.
Okay, that's good excuse, okay.
And now
So increase everything by 1. N go to n plus 1. N plus 1 go to n plus 2 for example. Okay?
Yeah.
And then you divide by this. So that means you flip them all because you divide it.
Yeah.
So you flip them all. You're gonna have 5 to power n. Over here you have 5n factorial x to power n. Right? So which one we can cancel out? N plus 1 factorial.
Oh wait, can you separate it? Can you like?
Write them in corresponding. Like this. Okay.
Wait. You can't
N
do
plus
that.
1 factorial
You can't-
divided by n factorial. What is it equal to?
N plus 1 factorial is 1. No.
No.
So-
N plus 1 factorial divided by n factorial.
Don't you cancel out the factorials or?
So it's just n plus 1?
N plus 1. Yeah?
Wait, is n plus 1
N plus 1
divided by?
factorial means n factorial times n plus 1.
Okay.
So divided by n factorial, you cancel this out,
Yeah.
you're going to have n plus 1. So this guy become n plus 1.
Idiot.
And this guy become
5. Wait.
1 over 5?
1 over
Yeah,
5.
1 over 5. That's what I meant. I just,
Sure.
I just flip it, you know?
Alright, sure. N plus 1 is 5 over power n times n, times 5, right?
Yeah.
We need divisible 5.
Yeah,
We need
yeah.
divisible 1, then you add them. So
That's-
cancel this out, you have 1 over 5. How
That's
about
what
this?
I meant. That's what I meant by like separating them. I was thinking like.
So term by term, right? Term by term and break them out.
And then.
How about this?
The one would be x.
Just that.
X.
Just x, very good, yeah. So you have x n times x and then still one x n, so cancel this with x. So now you have x over 5 times n plus 1. That's the value. How this is going to be conversion? Ratio test, they need to be less than.
1.
Ratio test, root test, all of this need to be less than 1 to be convergent. Greater than 1 is divergent. Equal to 1 is you cannot say anything.
Yeah.
The test failed. Okay? So you want it to be less than 1. And remember this is going to be limit though. Limit of n go to infinity. Limit of n go to infinity. That's the ratio test. Review this. Okay? This is a ratio test. Limit of an plus 1 over an needs to be less than 1. That's
Wait,
the
what-
ratio test.
What makes it not like work again?
Huh?
What makes it not work?
Equal to 1.
Equals 1.
Yeah. Okay, so less than 1, now think about this. What value of the x, so that this whole thing here is going to be less than 1. Now, you need to think about when the limit is up, when the n goes to infinity, what happened to this guy? Okay? One of the example we did, one of the question we did above, we have something like this. Which is good, because this is always less than 1, right? There's something here divided by something bigger, they're always less than 1, that's good. But look at this guy. When n goes to infinity, what happened to the n plus 1? When n goes to infinity, what happened to the n plus 1? It goes where? It goes to infinity, right? So no matter what number of the x, this guy will go to infinity. So how do you make this guy become less than 1? Only one possibility, which is
Divide.
what value of the x? Remember, radius of conversion is they're asking about the x. Okay? Huh?
0.
0. That's the only chance. Very good. Right? Because that only chance is I have 0 times infinity. That will be 0. Otherwise, no matter what number is this guy going to infinity. They're going to be exploded. So the answer is 0.
Oh.
Good job. Yeah? Make sense?
Wait, I get that.
You get that? Very good. Very good. Alright, now here is x plus minus 1 power n over n times 2 to the power n. Okay, they ask for the radius conversion again. Which test you going to use? Same thing with test.
Ratio.
Ratio test, right?
Because it's the power of n.
Well, radius conversion, 90% you're gonna use ratio test. Okay? 90%.
Yeah.
Yeah? Okay, tell me what to write. Either one of you.
Wait, I'm remembering.
Okay.
I forgot. Wait.
Oh, it's sigma? No.
The song?
Equals sigma? The sum of
The song.
limit?
Alright.
Okay.
Alright, we're.
Oh, we kind of suck.
Ratio test, how does it work?
Sigma.
We flip it. Alright,
You divide it.
We literally just did it.
You separate it. I forgot the beginning. I know the rest. I just forgot the
We
verse.
just did it 2 minutes ago.
This is what I mean when I say I have the memory of a goldfish or something. Like,
Ratio test. How do we do a ratio test?
Please.
Oh. Oh. Okay.
Great question.
Would you mind giving us a spoiler? Please. One last time.
Okay.
Okay,
Okay.
that's the value. Okay.
Oh.
Oh, we plus one all the ends.
Yeah.
You plus one all the end.
You
Okay.
add, yeah.
Okay, we got there.
Okay, so n plus 1.
Okay, we
2 to power n plus 1. Okay. Divided by an. An is this guy, the original one.
Yeah.
But you divide it, so what you gonna do?
We flip it.
You flip it? Okay, tell me what you write.
Oh my god.
Oh. You just, okay, so it's gonna be n minus 1.
N times,
2,
and then?
period. And then x plus the power of n.
Okay, so you want them to be corresponding, right? So we're gonna reorganize
You
them.
just flip it. You don't change anything.
So I'm gonna reorganize them in a way you can simplify it.
The laws of physics do not apply.
Okay, now tell me how to cancel this guy. One by one.
Okay, so
The
basically,
first part is 1 over. Wait, it's wrong. I'm wrong. Is it just x minus 1 for the first one?
The first one equal to?
x minus 1.
Oh, x minus 1. Very good. You got this. Second one.
So.
There's nothing you can do,
No?
right? This is just n over n plus 1, like 5 or 6, 6 over 7. There's nothing you can do. You cannot cancel out, okay? So n over n plus 1. How about this guy?
Oh, okay. Oh, that was the.
Yeah.
That was 1 over 2.
Yeah.
Yeah.
1 over 2, right? This means 2n times 2. So if you n 2n cancel, you have 1 over 2. Good. Very good. So this guy, oh, this is a good thing because they're already less than. Remember, radius conversion is you want the whole thing to be less than 1. But this guy is already less than 1. So now you just need to consider this guy. You also want this guy to be less than 1. Okay?
You want every like part of it to be the same.
Yeah, that's right. Okay, now
Where did he get that from?
so limits of n plus 1, if you consider this,
Oh.
what you're gonna do is let me take that one again. Take it back again. The whole thing here needs to be less than 1. But the reason why I said this one is okay because if you take it consider the limits,
It's gonna be.
you're gonna look it all, right?
It's gonna be 0.
Infinity over infinity.
0.
Not 0.
What? 1.
Why 1?
Because it's like the same. Like it's like 1 over 1, so over 2. No? Okay.
When n goes to infinity, n here become infinity,
Yeah.
n plus 1 is still infinity.
Yes.
So when you see this, what you gonna do? Huh? I just said it earlier. When you see infinity over infinity, what you gonna do?
Flip it off.
Flip it off. Okay, what is the derivative of n?
The derivative of n is.
1.
Yeah.
I
It's
just
1.
wrote it.
It's 1.
Derivative of n plus 1?
2. What?
Derivative of n plus 1.
Is it not 1?
It's not 1?
It's 1. You said 2.
I said 1!
Oh.
You said 2.
Whoa, what I
I
said.
did not say 2.
You said
Mr.
two.
Wee, you can like look that. You can like.
Oh,
look
okay, I
at the
look it like
recording.
that.
Yeah.
That's why. That's why when limit of this whole thing is become 1, so we don't need to worry about this,
Okay.
right? This whole thing become 1, right? So now I just need this guy to be less than 1.
Oh wait, now I know why I said 2. Yeah.
Oh, okay, okay.
Because like if you take the derivative of n is 1 and then I thought 1 plus 1.
Oh, okay.
No,
Now,
why doesn't it work like that?
no, because
Why?
you take the derivative of 1, it becomes 0. Alright,
Right.
anyway,
Okay.
so different from the previous question, this one you have something on the denominator.
Yeah.
So you need to multiply them so that you only have this guy by itself, no fraction. No fraction. Then what is the radius? We talked about this in class. What is the radius?
Mmm.
It's x.
The radius
That's
is
the number?
the radius is the number.
Mmm. So we're trying to find X.
Uh,
Not bad. It's not smart. No, I'm wrong.
0.5.
2.
The radius conversion is 2. This guy right here.
Oh.
This
Oh.
here is the center.
Mm-hmm.
Okay, center
Okay.
is greater.
Now another concept is they only ask you what is the interval of conversion. Interval of conversion. So this can be founded by take care of the absolute value. So x minus 1 less than 2. Remember how I showed you in class how you take care of absolute value?
Yeah.
You keep them the same and you flip it. Okay, tell me what you write. X, keep them the same.
Oh, minus 1.
Mm-hmm.
Greater than.
Keep them the same, keep them the same.
Less than 2.
Okay, now the second one you're gonna flip everything.
Now it's the greater than.
Greater than?
Negative 2.
Negative 2, that's right. Okay, solve this. So remember this is the radius of conversion. So solve this, what do you have? X less than? Oh,
So
thank
we
you.
can choose the.
Thank you.
You can share
You
it.
plus 1.
You can have it.
Less than 1.
And then give this Mr.
You want some?
I'm good.
I don't think I'm gonna
Yeah,
do
okay.
it.
No,
No,
I just ate.
that's good. Thank you, Miss Material.
Thank
Go, go, go.
you.
Yeah, it's good. Well, cut them now. All right.
What the hell?
Did you just tell her you're gonna cut us down?
I mean, because I'm recording.
Oh.
You
All right.
happy?
So x,
Oh, I thought
x what? X less than?
Mm.
1. Alright.
Solve this. What do you have? X less than?
This is
So
not
you're
what?
free?
3.
Oh,
Three.
dumb.
And then this one is x
Plus.
greater than?
Dumb.
Negative 3?
Negative
3.
1. Negative 1.
Negative 1.
No.
You move 1.
No.
You plus 1 both sides. Okay, so this will be your interval of conversion.
Mm.
So that's mean interval of conversion is negative 1 to 3, right?
Mm.
Greater than negative 1 but less than 3. So everything here. So that's mean from negative 1 to 3. So 3 concept you need to know. Radius of conversion, that's mean when you solve this to be less than 1 and see what number and eventually what did you get the number. That's the radius of conversion. No fraction, okay? No fraction. Take care of the fraction. Let me answer this again. Let's practice. Okay, what is the radius of conversion?
Okay, so you're gonna add 1. No. You're not gonna add 1? Wait, this has no n.
So.
No.
Radius of
Similar to
convergence
this.
is
Similar to this.
1.
He said the radius is 1.
What is the radius of conversion?
1. Okay.
When I have this less than 1, what is
Uh-huh.
the radius of conversion?
Oh, the one on the other side.
The number on the other side. But I need to
Move
take care of the
I'm gonna
bottom.
move it, yeah.
So how do we do this?
So it's gonna
So it's 4.
4 is the radius of conversion. Very good. Okay, this guy will be radius of conversion. Now what is the center?
Other side.
Negative 1.5.
They all will be minus, so the center is 1.5. Okay? If this is plus, then the center will be negative 1.5. They all will be minus. Okay?
Oh.
Now, what is the interval of conversion? You need to solve, right? You need to solve this guy less than 4, and then this guy greater than negative 4. Similar to this. Yeah? Interval conversion. So let's answer this one. The radius is 2. Right? Okay. Alright, 41. Similar amount, alternating series. Okay, alternating series, -1. Let's wait. Let's see what's that. To power n. Okay. So -1 to power n, this is alternating series. So alternating series, two things need to be satisfied in order for them to converge it. What are they? Two things. They need to be,
Massimo.
they need to be
Massimo?
alternating series.
To the power of n.
Alternating series.
Stop.
So you need to learn the knowledge.
Which
If you don't know the knowledge, you cannot do it.
Switch between positive and negative.
No. Alternating series is when they need two things happen. They need to be decreasing. We talk about this in
Oh.
class. And they need to go to zero.
Oh.
Decreasing and approaches zero. Okay? So when you consider function, check them like this, you don't consider the alternating. You don't consider this. So what do we have left? We have 1 over n squared. Is it decreasing? If you want to check
No.
decreasing, you're gonna plug in a number to see if it is decreasing.
It's decreasing.
So 1 over 1, 1 over 2 squared is 4, 1 over 16, right? 1 over 9. Is it decreasing?
Yes.
It is decreasing. Okay. Is it approach 0?
Yes.
Yes, so it's okay. So that's mean it is.
It's true.
It's convergent,
Yeah.
right? But we don't know whether it's going to be convergent absolutely or convergent conditionally.
What's conditional?
Conditionally is when you take in the absolute value and this diverge. So this is already converged.
Oh,
Now
because
I'm
it's
checking it.
positive?
Now I'm going to take the absolute value. Yeah. That's mean absolute value take care of the negative. So 1 over n squared. Is it convergent?
Yes.
Yeah. This harmonic series.
Yeah.
I mean not harmonic series, but
Yeah,
P
yeah.
series. But P series, right?
Yeah.
By P series, because the power greater than 1, the series is convergent. So the answer is
It's absolute.
absolute. Very good. Yes? Two things happen. You converge and also the absolute value converge, then it's converged. If it is converged but the absolute value not converged, then it's going to be converged
Conditional.
conditionally.
Wait, so like if there's an absolute value, it's conditional?
Yeah, if the absolute value fail, then it's conditionally.
Wait, how does it fail again? Just like repeat.
So for example, you have something like this. Okay? If you're taking absolute value, it is converged. But if you're taking absolute value, you only have 1 over n left. This is
Over harmonic.
It's still.
that harmonic, that's diverge. Right? It looks like you're thinking, so okay. Area between this guy. So y equal to x using the calculator, wrapping the
Is this like
function.
washer? No. Is this area under the curve?
Right. Y equal to x squared is this, right? You can use the wrapping calculator to get this. Some 0 to 1,
this
0
is. Oh
to
wait, I
1.
forgot. What's this called?
Is it top minus bottom, right minus left, right?
Yeah.
Depend on whether you do dx or you're gonna do dy.
Area
Is that
between-
dx or dy better?
The
Dx. Okay, so let's do dx. Dx mean top to bottom, right? Which one is the top?
so
One.
y equal to x.
Yeah.
Yeah. Which one is bottom?
X squared.
X squared. Okay, top minus bottom. From where to where?
From
Because this is about x, so you need to see where the x is. X from
0 to 1.
to
One.
okay. What integral of this?
So
X squared over integral. And this one is x cubed over
3.
from 1 to 0 to 1. Plug in 1, you're gonna have 1 over 2 minus 1 over 3. Plug in 0, they're all 0, so you don't need to worry about this.
What is this area between the curve? Yeah.
The area between the curve, yeah. So this one will be 3 over 6 minus 2 over 6, that means 1 over 6. Right? The answer is A. Area between curve.
I have like notes on this.
Yeah?
Yeah.
Okay. Volume by washer. So remember volume, you have 3 ways, or actually 4. Actually 2 big topic first. Either they revolving or they base up solid, right? Cross section. So this one is rotating. So that means you're gonna using washer this or shell. Let's say if this is the washer. So let's say y equal to square root of x. So the function y equal to square root of x is like this. Y equal to 0, this guy. X equal to 0, this guy. X equal to 4, this guy. Okay, so they're asking about this bottom of this right here. Rotate around a axis. So rotate around here.
Oh, this is washing?
So it's gonna be
This.
Wait.
This cause no. Oh we have double. Wait no.
Do we have all?
yeah, it should be
Yeah,
this.
it's
I don't know
this
about the
because no.
washer.
Volume by washers. Rotate.
But the same thing, this and washer, same thing, it's just hole, no hole. But I think this one is just this, maybe this. They put it wrong. Okay, anyway. So this is no hole, so it's gonna be, it should be this, right?
Wait, can you tell me what one with the hole looks like again? That's it.
Right? When
Oh,
you
yeah,
rotate,
yeah.
when you rotate
Okay,
it,
I remember now. Okay.
rotate it, you have a hole inside.
Yeah, yeah.
Right? You have two things, outside radius, inside radius. Remember? So washer is pi r squared. Yeah. So pi r is the radius. What is the radius here? So this guy, right? This is the radius. Remember, radius is the function minus the axis of rotation. So the function is square root of x. So square root of x square dx. Yep. Is it r squared dx or dy?
And then you like plug it in.
You need to plug it in?
Yeah.
From where to where though?
Top line.
0 4.
0 to 4. 0 here to 4 here. Yeah?
Yes.
So square root and square they cancel out. So you have integral from 0 to 4 of x dx. And outside you have pi. So that means x squared over 2 pi from 4 to 0. Yeah? So broken in 4 you have 16 over 2 pi. 0 is 0. 0 broken here 0 gone. So answer is 8 pi. Yeah?
For area between the curve, you can just use the calculator too.
Can calculator do that?
Yeah, remember we taught us the calculator method or whatever? For area between the curve. No?
Isn't that just a graph?
They're just graphing and it's just finding the intersection for you. For example, you
And
have
then
some
you just plug it into the calculator.
you have some complicated function. You
Yeah.
plug into function into the calculator, they give you the
Intersections.
the intersection.
Yeah, but then like you like plug in the function.
Right.
Yeah.
But you need to know how to set up,
Yeah, yeah.
right? And then you can put on calculator to get the answer. Yes.
I
Yes.
think I remember.
Yeah. So you need to know how to set up first. You need to just know how to set up.
Well, I remember.
Good. Very good. Very good. All right. Integral of from 1 to x of t squared minus 4 dt. They're asking about if f has a local minimum.
Okay, so first derivative is.
Very good. Every time you hear the word local minimum, maximum, tangent line, what else?
Slope,
Yeah, slope.
concavity.
That's about. I mean, local maximum, critical point, local minimum,
It's like derivative.
tangent line. That's about derivative. But what's special about derivative?
So like there's like the first, second, third derivative.
No. What is the special about the derivative when you hear the word local minimum, local maximum, tangent line?
You need multiple.
The derivative needs to be 0.
Oh yeah. Cause
Yeah?
like, yeah. Cause yeah.
Right. Okay. So they give you a function. They ask you about local minimum. That means you need to find the
Third derivative.
derivative,
Yeah.
right? You just talk about it. You need to find the derivative.
So like the first one's position, the second one is acceleration,
Yeah.
and then the third one what's 3?
3.
Just 2.
Okay. So you're gonna find the derivative of this by FTC. Derivative and integral they're going to cancel out. What are you gonna do with the x here?
We're gonna change the t.
You plug it into the t. What do you need to care about the one, the bottom one? No. Okay. So what do you have? X square minus 4. That's the derivative.
Yeah.
And then because they want to find a local minimum, that means the derivative needs to be
0.
0.
Oh.
So x squared minus 4 equal to 0. That means x equal to plus minus 2.
Mhm.
Now, how do you know which one is the maximum? How do you know which one is the minimum?
You do like the line chart thing.
Yes. So -2 and -2. The very right one going to be the leading coefficient, which is
Positive.
positive, negative, positive. So local minimum, where local minimum gonna happen?
Between -2 and 2.
Huh?
When,
Where's the local minimum happen? Is that -2 or 2?
-2. 2.
2 or -2?
2.
Why 2?
Because it's like going to it, you know? Like it's down. Yeah.
Right?
Yeah.
It go down, it go up, right? This is going to be the
Maximum.
max. And this is going to be, this is going to be the
Min.
mean because it go from negative to positive.
Yeah.
So the answer is
2.
C.
2.
yeah, 2. Yeah. Second degree Taylor. Okay, Taylor. Taylor is this, right? Right, that's Taylor. Now second degree, that's when they're talking about whatever x equals x squared, whatever term we have x squared. This one is okay. About x is 0. Oh, x is 0. That means what kind of information you can know from here? That means a is 0. Yeah.
Oh,
X is 0, about x is 0, that means a is 0. And that means they're talking about they're talking about
McLaren.
the Maclaurin. Okay?
Yeah.
Alright. What function do we have? What's the first step? You said in class today. What's the first step? Is it you or Valerie? You're
I
Valerie.
think it's Valerie.
The first step is always list out the function, first derivative, second derivative. Okay? They asked about second degree, so
Wait, the first step for McLaren or Taylor?
both of them. The first step is write down the function, the derivative, first derivative, second derivative. Okay? What is the function?
The function
Is it the 3 plus 2x?
Oh, okay. Now this one they asked them different thing.
is.
They say second Taylor, they already read you. It's going to be 3 plus 2x minus 5x squared. They give you already. This is the second Taylor derivative, second Taylor degree. Okay? Now, if I want you to expand this guy, how do you write it? The first term is f of 0.
Yeah.
That means a. Yeah, a is 0. f of a.
Okay, yeah.
X to the power 0 over 0. Right? That's
Yeah.
first term.
Oh, yeah.
First degree. F derivative x to the power 1. Right?
Oh, yeah.
Second degree. F second derivative x squared over 2 factorial. That's second degree.
Yeah.
And then third degree, same thing. You can increase it. Okay? They're just asking you to matching the term. This guy will be equal to this guy. This guy will be equal to this guy. And this guy will be equal to this guy. Okay? Now they ask you, what is this then?
What
Where
is
do
that?
you see this guy?
Negative 5x.
The last one.
This
That
guy right here, right?
Yeah.
And I know that this here will be equal to this. So let's
negative
write down.
five.
So
F double prime here times x squared over 2 factorial must equal to negative 5 x squared. From here, can you solve for this guy?
Yes.
Right? X squared gone. 2 factorial is at 2. So x double prime here equal to negative 5 times 2. That's negative 10.
Yes.
Which is?
10.
It's just matching the term. Yeah?
Yeah.
let's see.
Study Taylor series.
So what's good?
Is
Yeah.
that the last question?
No.
What?
Is it?
Yeah.
Yeah, it is. Huh?
Oh, is it? Oh, okay. Let's pause it. Alright, f of u, population, you have dy over dt. Simplify dy over dt equal to y over 10. 8 minus y. Similar to the one on the MCQ we did earlier. F of 0 equal to 10. Okay. If equilibrium solution is when dy over dt equal to
0.
0. That's the free point for you.
Period.
So equal to 0, that means y equal to, solve this.
Is that 8?
Yeah, y over 10 times 8 minus y.
And you want to have y on the side, right?
I want whole thing equal to 0. That means each of this needs to be equal to 0.
Okay.
This equal to 0 or this equal to 0. So y equal to? You stuck on
Zero?
this? Huh? 0. And y equal to?
Alright.
8.
Yes. This
Okay.
equal to 0 or this equal to 0.
Oh,
Yeah,
you take the
I was getting confused
oh.
because I thought like you had to find like the same number of y for both of them.
No. Yeah,
Okay.
Yeah,
or.
something
Yeah,
like
and I
This,
was like,
this equal to 0 or this equal to 0.
yeah.
Something we solved in answer 2 in here, remember?
Yeah.
Yeah? S plus 3, yeah? Yeah, so you got this, okay? That's the answer, that's it.
Oh.
Alright. Oh, describe the long-term behavior.
Alright.
So, long-term behavior, still we have dy over dt. You can see dy over dt and you can see the, if you remember the when velocity and velocity acceleration both rated the same side.
Yeah.
That's mean they're speeding up or slowing down.
Speed up.
Right. If they have different side, they're going to slow down. Yeah.
Yes. That's it.
So what is this thing? What is this one?
Oh.
So it's going-
okay.
so it's speeding up?
Speeding up or slowing down?
I say speeding up.
Okay, wait. So identify equilibrium solutions just means that you need to make them below 0. Right?
Yeah.
So f of 0 is 10, right? F of 0 is 10. It's greater than 0, but dy of dt when you plug it in 10, if y equal to 10, this is y equal to 10. When you plug it in 10 here, you're gonna have negative, right? Because y 10 over 10 equal to 8 minus 10. So that's negative 2. That's negative. So that means the function is decreasing. Right, it's decreasing. Euler method with 2 equal step. So if I want to go from 0 to 1 with 2 equal step, that means what is my step size? I want 2 step, then what is my step size?
0.5.
0.5, right? I want to go from 0 to 1. I don't want exactly 2 steps. That's in each of my steps, it needs to be 0.5. And Euler method, remember I draw the table here? Xn and what, oh in this case going to be t. Can I use t? So tn and yn, okay? I need 2 steps, so 0, 1, 2. First one is 0 because they say f of 0. What is when t equals to 0, what is y? 10. Now what does the Euler method look like? y1 equal to the previous step, the y 0, which is 10, right? But later we're gonna plug it in. Plus h, which is the step size, times the derivative, right? Times the derivative. That's the Euler method.
Mister, what's that? Like up there?
You see?
Yeah, what's that?
F0. F0 equal to 10.
Oh,
So F of 0 equal to 10. This is positive, but this guy here is negative. So that decreasing. Alright, so let's find y1. So this is going to be 0.5, it's going to be 1. You know that because we want 2 steps. So y1 will be equal to y0, which is 10, plus h. H is 0.5. How do you find this? You need to plug it in. You need to plug it in the formula that you here.
Okay.
Right, so 10, plug it in here. I have 10 over 10, 8 minus 10. So 1 times negative 2, which is negative 2. So that's negative 2. So 10, this is 1/2. So negative 2 divided by half is negative 1. So it's going to be 9. Yeah? That's my 9. Now next step, y2. Tell me what you write. y2 equal to?
The previous one should be 9.
So y1 should be 9. Okay, you want to break it into. Let me just write out so people watching it and they know. 0. There is 1. Okay, so y1 which is 9 plus h. What is the step sign?
0.5.
Always. Okay, they're going to be fixed. I mean, they're going to be fixed depending on each problem, but it's going to be fixed always for every calculation here. Y gram of 1. That means you need to plug in 9 into the
New equation.
into the derivative. Okay, so plug it in here. Y divided by so 9, right? 9. 9 over 10, 8 minus 9. So that means 9 over 10 negative, right? 8 minus 9 negative 1. So negative 9 over 10. So plug it in here. Negative 9 over 10. So again, 1/2 means 0.5 means 1/2. So we're going negative 9 over 20. 9 here. So it's 180 over 180 minus 9 over 20. So that means 171 over 20. Yeah, so the answer here is going to be, so it's going to be 171 over 20. This sort of two equal step to approximate, yeah. T equal to 1. F T equal to 1, yeah.
Right there, like the first part, like the y1. Okay, so it's y1 equals y0.
Y0, the initial one. Y0 is 10.
But like, why did he put it equal to y1 and then equal y0?
Oh, the Euler method formula is y new equal to yo. Like,
Oh, okay.
remember the previous one?
Oh yeah,
The previous one.
yeah.
This similar to the point slope. Y equal to y0 plus m x minus to x0. Remember the point slope?
Yeah,
So
yeah.
these two number here is the previous step on the order. So for example, y2, you need to start from the previous step, which is y1. Yeah, make sense? Okay, so that's the answer for the B.